Good evening everyone. We are the second years and we are today going to present one of the most important and valuable resource on earth, that is water. Water covers over more than 70% of earth, yet still even less than 1% of it is actually accessible for us. Even though it's less than 1%, we still overuse it, over extract it and waste it. Therefore, today we're gonna discuss about water resources and its pollution. So mainly we're going to focus on availability of water, water pollution, impacts of water pollution, and few cases related to it, and lastly water polluted impacts. I hope you guys all listen to it carefully because it's not only just for educational purpose but also how we can actually use all of this to implement it in further implement for further knowledge. Thank you so much.
So hello everyone, our group is going to present on topic availability of water. So firstly, water is the most essential natural resource of our life, agricultural and industrial side respectively. And mainly the next one is where does water came from? Mainly water came from natural and artificial sources. The natural resources are river, pond, lake and rain. And rain is the most essential part to harvest the water. And the natural resources play a major role in sustaining our environment and our human lives. So next point is artificial source. The artificial sources are man-made sources to store and supply water, and these artificial sources are reservoir, canal, well to supply water to through the irrigation and for the agricultural purpose, and through the different cities and through pipeline connections. And now next point is major water sources in India. I mainly focus on three large rivers, Ganga, Yamuna and Brahmaputra. And so first is Ganga River. Ganga River contributes around 525 billion cubic meter per year, and which India's 40 to 45% population depend on the Ganga River. And the next Yamuna River contributes around 70 billion cubic meter per year. And the Brahmaputra River also contributes around 600. And those three rivers contribute around 60% of India's land water resources. And so from these rivers, the water usage in India around 700 to 800 billion cubic meter per year. And from this side, 80% of water used in irrigation purpose. And the irrigation water use around 600 billion cubic per meter from above mentioned 800 billion cubic meter per year. So next point is the Himalayan glacier rivers. From the Himalaya glaciers are primary source of to store the water. In Himalaya region around has 9,500 to 10,000 glaciers, and which has those glaciers contribute the major role in Asia's largest freshwater reservoir in form of frozen form, and those water in the frozen form is around 13,000 billion cubic per meter per year.
What's the source? Where do you find all these numbers? What's the source?
I mentioned in convent the sources.
Where it is roughly?
Roughly around the government climate side and Gulf region, from the glaciers are melting. That.
Okay, but the river data you got it from?
And river data is also from the government river side.
Government. Okay. Continue.
So next part is from.
So let's have a look at the global distribution of water. As you can see that 97% of the total water is oceans, which we can't use for our daily lives like drinking, irrigation and all. The remaining water, that's 3% is fresh water. And in that 3%, 68.7% water is locked in glaciers and ice caps. And 30% water is underground, which is very expensive to use. Like if we want to extract the groundwater, then we have to install bore wells and all. And the remaining 0.3% is surface water, which we are using, like the water flowing in rivers and lakes and present in ponds is surface water, which we are using for irrigation, for drinking and daily lives. The 0.9% water is present in environment and soil and all. So this is the ocean distribution of water. As in previous slide I discussed that 97% of the water is in ocean. And now see how that water is distributed in different oceans. You can see almost 50% water is in Pacific Ocean, 23% water is in Atlantic Ocean, almost 20% water in Indian Ocean and a very few in Southern Ocean and Arctic Ocean. So let's have a look at how rivers are irrigating different continents. You can see that Asia is getting 30% of the water of rivers. At the same time, Australia is getting only 1% water of the river. So later on, we'll be discussing what are the factors which are affecting this uneven distribution of water. For now, just have a look like how different continents are getting what percent of the river water. So this is the global water withdrawal. As you can see that from 1900 to 1950, the rate of water withdrawal is very minimal. But after 1950, it has increased suddenly. The possible reasons are industrialization, agriculture, because as you can see after 1950, many countries adopted industrialization and agriculture and all. That's why the demand of water increased and withdrawal increased. So this is the how we are using fresh water in different activities. As I told you that only 0.3% of the fresh water is in rivers and all, and only 3% of the water is fresh water. But from that fresh water, 70% water is going into agriculture, 22% in industry, and only 8% is for our use. So this is the division of the water. So I have a question for you guys. Can anyone guess which country is withdrawing the most water in the world?
China.
No, it's India which is withdrawing most water in the world. It's about 760 billion meter cube per year. On the second, it's China, almost 581 billion meter cube per year, and on the third, it's US. So this
One quick question: why India has the highest withdrawal of water?
due to the highest population, and in fact second highest, but China is having highest, but they are using lower water in agriculture and industrialization all, but India is having a bit more.
India's highest population.
Highest population, but look at the number. I mean, still there are other factors. Population is not the only factor which is depending on the water. So, agriculture, geography, what's the average temperature what you see in India? That's also related to the water consumption, agriculture, all these practices. That depends a lot. Please continue.
So this is the graph like how countries are withdrawing water and how the per capita water is available for different countries. As you can see, India is withdrawing the most water, but the per capita water availability is lesser than US and in fact than Australia. So why is it so? Because our country is having a lot of population. Due to population density, the per capita water availability is lower than US. And you can see Australia is withdrawing a very few water, but they are having a lot of water availability per capita due to the same reason. They are having less population density, that's why they are having a lot of water availability. So this is a simple scenario like how 1% of US is getting as much water as 33% of Nigeria are getting for the same.
Jogendra, again go back. Just explain again like why the per capita consumption in countries like USA and Australia is higher.
Sir, because they are having lower population density than India. So this is the one reason that they are getting more water per capita.
That's the main reason.
That's the one reason.
Any other reason you can think of? Lifestyle.
of use
Okay.
and urbanization also.
Urbanization, industrial scale, what kind of industrial activities they are doing, that also depends a lot. But good, continue.
So this is the water availability across India. As you can see that the average water available per capita per year is 13.41 lakhs liter. But in some states like Ladakh, Delhi and Rajasthan, it's 1.54. At the same time, Arunachal Pradesh is having 100, Meghalaya 80. So why this is the uneven distribution in India itself? This is because that like rain are flowing in northeast and rivers are flowing in northern area, and the coastal region Karnataka and Kerala are being influenced due to the higher cloud formation due to sea and all. So this is the like distribution, uneven distribution in India. So I have another question for you guys. There's enough rain in UP, but still it's having lower water availability than Rajasthan. Why?
Density, population
Yeah,
is very much.
it's due to population density. So these are some drought-prone areas. As you can see that this is mainly in southern western part of India due to the lesser rain start from that plateau region and all. So that's why these might be possible reasons. Another question is, where does the IIT Gandhinagar water comes from?
First is where's the water come for IIT Gandhinagar comes from?
From the river we have.
Which river? Huh?
Sabarmati. Narmada.
Yeah.
Narmada.
जानो अपने कैंपस के बारे
IIT
में।
Gandhinagar is receiving most of the water from Narmada Canal. It's about 4.6 million liter per day, and it also have a rainwater harvesting system around 42,000 meter cube rooftops, which can store more than 25,000 meter cube water, which can last for 40 to 42 days. And the third source is borewell, which is used for supporting campus during supply interruption. And the fourth one is recycled water. Water we are using in our daily lives is being recycled and is being used in irrigation, in construction, and spraying on the grounds and all. So this was my part. The factors affecting water quality will be discussed from you.
Yeah, like one thing before that, do you remember when there was a water pipeline blockage and we got an email? Where do you think the water is coming from?
Jalmanda. Jalmanda.
Borewells.
Borewells.
That's why we need so much multiple of the sources to fulfill the demand. Okay, continue.
Jalmanda, Chinese.
So before we even talk about the water pollution, we need to understand something more basic. So why water is already scarce? So today I will walk through the factors which affect the water availability. So the first factor, natural factor is climate. As the global warming is rising, the earth is now 1.29 degrees Celsius warmer than the pre-industrial level. So as the planet is warmer the air, the water evaporates faster. So the rivers and lakes dry out more quickly. Also the rainfall pattern is also shifting. As we can see that Amazon and Southeast Asia and Central Europe get wet. These are the wet regions and get more rainfall. But the dry regions like Sahel and West Asia get less rainfall, up to 22%. As just the climate is changing, it does not just warm the planet. It's also the rainfall pattern is also associated with the climate change. Also, glaciers are retreating very fast, and the Himalayas are feed 8 major rivers of If by 22nd century, if the 80% of the glaciers is gone, these rivers will shrink. And drought in 1980, just 8% of the land was under drought, but by 2024, 29%, it means one third of the land was under drought. The second factor is geography, which means location. It means where you live decides how much water you get. In India, we can see that Meghalaya gets 11,000 mm per year rainfall, but the Kutch, which lies in the Gujarat, gets only 200 mm per year rainfall. Same country but different, same state but different water reality. This is a 55 time difference. Also the difference is caused by the Western Ghats rain shadow. The windward side gets up to the peak of 6,000 mm rainfall, but the Deccan Plateau only gets 700 mm rainfall. Also, terrain also matters in the groundwater recharge, as the hilly areas does not hold the water for a time to percolate to deep under the ground and recharge the aquifers. But the flat plains like UP and Punjab has a flat plain, so the water is go under the ground and recharge the aquifers. But later we see that overstructure now reverse this. The next factor is human factor, which is population growth and urbanization. India's population grew 4 times since 1951, from 361 million to 1.44 billion. But the rivers can't grow. The same water has to provide 4 times more people. So the result is that the per capita water is drastically down by the 74%, So India is now officially water stress country. As we declare water stress country, the country which has per capita water of 1700 meter cube. It's only 41 meter cube per year. Also, as we grow, the urbanization is also growing. So in India, urbanization is also growing. Cities use 3 to 5 times more water than the rural areas. By 2050, 55% of the India will be urbanized. So the water demand is increasing sharply. So our next factor is industrialization and groundwater over extraction. India's industrial demand is grew 3x by 2050 because industry need water for production, manufacturing, and processing. Meanwhile, the water extraction rates is dangerous. Punjab extracts 166% of groundwater recharge. It means it is extracted more than the recharge. 66% more extraction by Punjab. Also, the Rajasthan and Haryana and Delhi, they water drawn that the not filled by the century. We can thought that the groundwater recharge is renewable source, but technically it is not because it is centuries to fill. So why we factor this, because 85% of rural India still depends on groundwater for drinking. If we don't concern this, this is just not the environmental concern. This is the public health crisis if we don't concern these factors. So the last factor is seasonal factors. This is the monsoon dependency of India. As we see that 75% of annual rainfall is just in the 4 months, June to September. The problem is that the storage. India can only store 253 billion cubic meters, but has a 690 billion cubic meters of utilized surface area. So 65% of water just flows to the runoff to the sea. Also the demand is also increasing. As by 2030, demand will exceed supply. So the tipping point is less than 4 years away. So last, as to conclude that water is scarce due to the climate, human and seasonal factors. So before counting the pollution factor, we need to address these factors at first.
Just very quick question and a weird question actually. Because of climate change, now the rate of melting of these glaciers is much higher. But are we seeing more flows in our rivers or not? It's a question to all of you. Just take a guess.
We can see, but the more the water is flowing, but they could directly go to the ocean. So we can't take out so much water and use for the our uses.
And if you are getting more water into the rivers, you can take more out. That's why I wanted to ask. First of all, is the amount of water is higher in the rivers or not? What do you think?
The glaciers are melting, like the glaciers in Atlantic are melting, they're directly submerging into the
Let's
ocean.
talk about India. So let's say Himalayan region, where the melting of the glaciers is higher. So are we seeing more water in our rivers or not? What do you think?
Not
Or have you read about it by any chance when you're preparing the lecture somewhere?
No.
No.
So maybe the upstream region are getting more water, so till it come to the downstream.
What do you mean by upstream getting more water?
So once it starts to melt, so there may be some case of hazard in the upstream area, but in the downstream,
It's not reaching out that much. I mean, honestly, I was asking what's your views on that. I don't think there is a proper study on that which have identified that. But at the same time, when we are talking about the impact of climate change is increasing, at the same time population is also increasing. Which is increasing faster? We can't. Population is faster. You are right. But the effect of the population drawing that water, we cannot say that. Chalo, let's go next one. And always when you are starting the presentation, always tell your name and what's the topic which you are presenting.
Hello everyone, I am Rohit Kumar Meena and I will be talking about water scarcity. So, think about a village in Punjab or Rajasthan. A canal or river runs nearby. You can see the water, but it's carrying agricultural chemicals, industrial runoff, and untreated sewage. So nobody can drink it, nobody can irrigate with it safely. So the water is physically there, but it is functionally useless. That is physical scarcity. Nature supply is either insufficient or what exists has been so degraded that it might as well not be there. Now think of a village in sub-Saharan Africa. Clean groundwater sits just beneath the surface. Geologists know it's there, but no well has been drilled, no pipeline has been built, and no government budget has reached that community. So water exists, but it simply cannot be reached. That is economic scarcity. And important thing about it is that it is entirely man-made, which makes it entirely fixable. Therefore, it is hard to accept that it exists at this scale. And 25% threshold on the slide, the point at which a region is officially considered water stressed, sounds modest. But think of it like a bank account in which every year you are withdrawing 25%, with nothing goes back in. So the account will run dry in within few years. That's the situation of aquifers and river systems across water-stressed regions.
Just one big question. So you mentioned in the economical scarcity part that it is man-made or depending on the man. How does it?
So, it can be fixed with the technology of our time.
Okay. Yeah, but
It's the lack of resources which are.
because of that this is how.
There are 5 major causes of water scarcity. Starting with population, in 1950 the world had 2.5 billion people. Today we are past 8 billion. The Earth's fresh water didn't scale with us. So it's the same water now split between more than 3 times people, farms and cities. And the regions, fastest growing regions tend to be the ones already facing most severe water stress. Climate change then magnifies that pressure. Altered rainfall patterns create longer droughts and short, violent floods. And according to the slides, terrestrial water storage has dropped 1 centimeter every year for 2 decades. That's not a rainfall variation, it's a structural loss recorded by satellite. Himalayan glaciers are also retreating. Himalayan glaciers that feed India's perennial rivers are also retreating, and IPCC is explicit that even 1.5 degrees Celsius of additional warming will significantly reduce water availability across South Asia. Agriculture uses 70% of world's fresh water, which slide rightly point that much of it is wasted. Like in India, flood irrigation, simply flooding the field and letting crops absorb what they can, loses approximately 40% to evaporation before a single crop benefits. So we are losing irreplaceable water to methods which we have affordable alternative to. Then pollution takes what remains and makes it unusable. Like over 80% of wastewater flows back untreated into the same source people rely on. There, and poor infrastructure means untreated treated water never arrives. Like in US, loses 20% treated water to pipe leaks. Mexico City between 40 and 70%.
Any idea what's that number in India?
Indian aspect I have not covered. There are 5 major impacts of scarcity. So like 2.2 billion people without safely managed drinking water. Safely managed means treated, stored cleanly and available when needed. Not just a source nearby. So over a quarter of humanity cannot afford that basic guarantee. So the cost is borne most heavily by children, like more than 1,000 child death, preventable child death every single day. related to water diseases. Then agriculture on food, 70% of fresh water goes to agriculture, which used to feed the world as it is now. By 2050 we will know 50% more food. So that equation has not a simple solution without a dramatic improvement in how efficiently we use water. Economic loss, economic figure given by World Bank says that water scarcity could cut GDP up to 6% in most affected regions. A country like India can, for country like India, that's not a that's a cap on development. And more than 700 million people are at the risk of displacement, which makes like more than 50 countries share major river basins. So when these rivers shrink, the agreements made during better times will also break down. And the Aral Sea on ecosystem point is the most extreme case study of what happens at the end of that road. Once the fourth largest lake in the world lost 90% of its volume by agricultural diversion. Fish industry collapsed, communities around it also gone, and this shows what happens when we treat water like if it were unlimited.
Can you just go back? So basically the main 5 threats which you are mentioning, one is health crisis, food insecurity or because of agriculture will go down, economic losses, displacement and conflicts which is happening between the region, states and the countries, and ecosystem collapse is wetlands, river ecosystem, river body, lake body as well.
Median aspect has been covered by detailing by Piyush, and if we focus on the snapshot on the right, it highlights that 54% of India is already in high to extreme water stress. That is 600 million people faces extreme water stress, and 21 major cities including Delhi and Bengaluru are projected to exhaust their groundwater by 2030, and inadequate water access lead to approximately 200,000 or more deaths per year in India. That's all.
Hi, I'm Alok, and we are going to talk about water conservation and sustainable use. So, India sustains about 18% of total global world population, of which only 4% global fresh water is available in India, and over 85% of our agricultural demands, which limits the margin for industrial use and domestic uses, and for more than 14% are overexploited blocks. Overexploited blocks are the areas in which we extract more water, the water way more faster than it is being recharged. Now, what is sustainability? And this mainly means that meeting the current water needs without compromising the future generation. And previously, we are using linear circular water management, but now we are moving to circular water management, in which we reduce, reuse, and recycle. As you can see the diagram. Now,
Try to explain like each and every, how do you wanna do it? Just go back and try to explain how you reduce, reuse, recycle, restore.
okay. Now, first one is reduce. We reduce water by using,
Using water efficiently.
yeah.
That's quite clear.
The
Okay.
second is we reuse. The water going to sewage, we can recycle and then we can reuse it.
You can treat it and then reuse it. Okay.
And then next is we can recycle by treatment plants. And
How this reuse after treatment and recycle is different?
like in reuse, we can use the water coming from kitchen sink. They are called grey water. So we can use double tap system. So we can wash. We can use the grey
Use
water
it for flushing and these kind of activities. Okay, so that is reuse.
Yeah.
Recycling is more of where treatment is got involved. Okay.
And
how
then
does
also we can restore water by rainwater harvesting system and other.
good. Next one.
And this is some method. There are some methods of our water conservation. The first one is, as we have seen that agriculture demands are of 85%, where we can transition to micro irrigation, which is also called drip irrigation or sprinkler system. This increases efficiency by over 40 to 70%. And the second is we can install rainwater harvesting system. We can mandate in buildings, and also we can use dual plumbing system for grey water use. And the third is we can recharge aquifers artificially and build check dams, and also we can manage watershed like rural ponds and other. These are some national schemes. The first is Jal Shakti Abhiyan, which catches the rain. It builds over 4.7 million of water conservation structures in India. And the second is Atal Bhujal Yojana, and it transitioned over 9 lakh hectare of micro irrigation in agriculture sector. And the third is Amrut 2.0.
What is micro irrigation?
Like there are plants
It's fine. It's fine. Yeah.
and there are short pipe, thin pipe. So there are some, मतलब उसमें ऐसा होता है कि पानी निकलता है तो ऐसा स्प्रिंकल करके तो ड्रिप इरिगेशन कर सकती है, या फिर थोड़ा सा पूल रहता है उससे like
So it's kind of a drip irrigation or bit different than that?
micro irrigation.
हाँ भाई पूछना चाह रहा
Yeah.
हूँ. How does it different than drip irrigation or is it same?
ड्रिप इरिगेशन माइक्रो इरिगेशन में आता है.
Okay. So they are वही मैं पूछना चाह रहा हूँ. Other methods like where you are using smaller pipes, that kind of a thing or
स्मॉल मतलब जो प्लांट होता है पर्टिकुलरली उस पे वाटर जाता है, बाकी जो एरियाज रहते हैं मतलब उस पे नहीं, पर्टिकुलरली प्लांट पे फोकस करा जाता है, वहाँ पे वो वाटर.
are we using that kind of a technology already in our country?
हाँ.
कहाँ पे? Any idea? And just one thing, when I am answering question to him, asking question to him, you all are in a single team. Feel free to answer. हाँ तो उसको बता दे कहाँ पे लिखा होगा.
9 lakh hectare of agriculture land converted.
हाँ.
वही यूज हो.
Transition over. कहाँ पे change हुआ? That's what I wanted to ask. I mean, see, in India is an agriculture economy for sure, but not all the agricultural areas are developing with the similar pace. So, any idea? Go on. Next, continue. Go on.
And the third is Amrut. It mainly focuses on circular economy principle. It mainly targets to provide 2.68 crore new taps connection, and it mandates 20% of their water demand through recycled sewages. And the last one is Mission Amrit Sarovar. It mainly aims to construct standardized ponds, to manage watersheds. Over 16.3% increases in national water body surface and 42% decrease in dry water body. And these are some innovations which are in practices. The first one is smart water grid system. In Pune, it is implemented citywide. It tracks pipeline pressure, and it detects the exact location of the exact leak location, which can reduce non-revenue water. जब तक टैप पे वाटर पहुंचता है तो उसके पहले जो वाटर वेस्ट होता है उसको कम करने के लिए. And the second is waste water valorization. This is implemented in Surat. They successfully sell millions of liters of treated wastewater to their local textile industries, and they uses sewage slush to extract biogas, and they are implementing to
generate electricity on their side. And the last one is climate adaptive infrastructure. There is a place Rotterdam in Netherlands which is also called Clean Water Square. It is also called Spawn City. In dry weather, this water square act like amphitheater and skate parks. But when heavy storm comes, it has walls which opens and it contributes like a massive basin which can hold about 1.8 million of liters of flood water. Yeah, sources.
Good.
I am Nidhi and I'll be talking about importance of studying water resources. So a lot of the topic that I'll be talking about is already covered by the last team. So I'll be giving an overview from a global perspective. So even though water is apparently very abundant, but then it is very scarce and limited to our use. And then we need to study these water resources so that we understand how it's distributed, how it's used, and our impact on like human activities impact on these resources. So why study water resources? Like I said, 90% of the earth is covered with water, 3% fresh water, 1% is the actual usable fresh water. And then there's a lot of growing population that is pressing stress on these resources, and then there's climate change that affects the variability of these resources. Then coming about next, global water crisis. So global water crisis basically states the scale of this issue. So according to UNICEF, there's already 4 billion people, almost 2/3 of the world's population, does face water scarcity once a month per year, and then by 2040, 1 in 4 children will be facing extreme water scarcity, and then by 2030, 700 million people will have to be displaced. So, like, the issue isn't just a future issue, but it is currently happening, and it is happening at a really big scale. Now, coming to water is again unevenly distributed. So, water does not follow political boundaries like states or countries. So there's like 263 rivers and ocean bodies that are distributed among 45 different countries. And then there's it's like on a single river, a lot of countries, a lot of states are already dependent. So then there's over extraction of these resources, which leads to depletion of groundwater resources, and this might also then like bring in the contamination from the lower levels, for example heavy metals or high salinity, etc. So this is a graph of the groundwater level of wells in 1992. So this problem isn't new, it's been going on, and it's been going on for a lot of time, and it's still just increasing. Now virtual water. So virtual water is a term that we use to refer to the hidden cost of water that are used in agriculture or industries. So there's agriculture itself uses like 70% of the fresh water resources. So like I said, 1 kilogram of beef requires 15,000 liters of water. 1 cotton t-shirt for the production, we need 27 liters. 1 cup of coffee requires 140 liters. So like there's an hidden global economy going on, like trade of water for these industries. So we need to study these resources so that we know, like, when drought occurs in one region, how it will affect the economy or the food prices globally. And then there's also eutrophication due to agricultural runoff, which leads to depletion of oxygen in water bodies, etc.
Like, when you are studying these numbers, you are also getting prepared in worst case scenario if you have limited water available. Which are the non-essential things you can go away from actually? And just curious, like, what do you think, for example, why producing One cotton t-shirts require 2700 liters of water.
First, so I think there's a lot of agricultural process like
Cotton.
irrigation,
Cotton,
and then
fabric, all
there's
those things,
energy
okay.
requirement to run the machineries, etc.
Where the water come into that? I mean, energy, I got it.
Yeah.
You are right. So where
The
the
electricity part.
Okay.
And then like that are the two major things that we think of.
Also in textile industry, water is used.
Yeah.
So in the industrial processes itself, there is lots of water consumed in the process itself. So for example, the dyes, which are
Yeah.
used for the color, predominantly most of it's the water. Only a drop or a little amount of it's the actual dye which is used. Continue.
Now, a major issue that we are facing is the emerging contaminants. So, what happens is like now the effluents. So, a major term in this is the PFAs. So, these are chemicals like microplastics. They do not degrade easily. And then, like the food chain, we study the food chain. These can be found in our bodies, etc. These accumulate over time. And then there's microbial resistant bacteria. So what happens is like our humans feces or pharmaceutical waste, when these combined with industrial waste, so there's a lot of, they become resistant to the anti microbes present in our body, and so these leads to diseases that are hard to treat from the anti microbes that are used. So examples of this is like there's this emerging tuberculosis. So it can't be treated with our normal tuberculosis practice, and then we do not have the treatment system right now. Like we still have to study about it and still have to make more research. And as we can see, around 56% of the global wastewater has been treated safely. So there's like still 44% more that has not been treated properly. So this again, then this gets.
Any idea what's the number for India?
I know it's more than 60. I read it.
Anybody else has idea? I guess क्या मतलब 43 would be that precise. It's much higher. चलो continue.
Okay. So yeah, this water then goes on to our river systems, oceans, etc., which leads us to the safe water part. So safe water is really essential for human survival. And then contamination of water resources leads to various diseases like cholera, typhoid, hepatitis, polio, diarrhea, etc. And then one of the major issues is this Indore case where a lot of people died due to contamination. What happened was like a sewage pipeline was matched with the water supply pipeline.
Sewer line is basically apart from like this.
Yeah.
What's the wastewater coming in the sewer line goes into the drinking water supply.
Yeah. And then conclusion. So studying about water resources, it isn't just like a geographical part anymore. We need to study it from engineering perspective, economic perspective, environmental science, everything. And then water scarcity is just growing, so that is also one of the major factors. And then it is like one of the most prior or foundation of our economy.
I'm Radhika, and I will introduce the major sources of water pollution and explain how natural and human activities impact water bodies and how it degrades the water quality. Here we can see this. So before that, let us classify the sources. There are two types of sources, point source and non-point source. Point sources are those which we can directly see, like they are single and identifiable. Like we have wastewater effluent, the pipes coming out of the factories that discharge the wastewater in water bodies. Then we have non-point sources. Those are the sources which we cannot directly identify. Like it is difficult to identify. We know it's happening, but we don't know when and where it's happening. The common example of it is runoff from agricultural fields.
Or another definition of non-point source is it could be a bigger area which is contributing to that rather than just being in a small or specific location.
There are multiple, not a single identifiable source.
Yeah.
There are multiple sources.
Multiple sources. That's important to mention.
Then there is one more term, transboundary water pollution. It is right now globally very much big concern. What is it? It's it is the result of contamination of water at one place and causing damage at another place. And it is like you can see oil spill in oceans that happens at one place. Effects are can be seen at different places. Then we have the crop fires we know in our India also. Here we can see different kind of non-point sources and point sources.
Here it's quite clear, like which are the point sources and which are the non-point sources.
Agriculture is, we know all that agriculture is the major consumer of fresh water, but it is a serious polluter as well. 70%, as our friends told, 70% of fresh water is being consumed in agricultural activities, but it also produces a lot of waste, like pesticides and fertilizers. They run off from fields and enter into water bodies, causing eutrophication. And now it is a big concern, as we can see in this picture. Those are algal blooms. Then we have sewage and wastewater. Sewage comes from sink, shower, then toilets, those kind of those things contribute to the sewage and wastewater. They accumulate, sometimes if not treated well, they can accumulate and damage cause to animal. Then we have oil pollution. In ocean, it happens when oil is being transported, but there is some leakage in the tanks and all, and it spills out and causes damage to the ocean. One more thing is oil pollution also happens on roads and as well. Like oil and gasoline, they sometimes trip a lot from a vehicle and they just run through the sewage, as you can see in this picture. Then we have industries. Industries cause, it is the second most serious polluter after agriculture. As we can see in this picture, you can directly identify that it is being polluted. It is not a natural water body. It is being contaminated by several chemicals and dyes and all. Dyes coming from textile industries. Then, what are those chemicals? Those chemicals include heavy toxic metals like lead, mercury, and chromium. Then we have pollutants like dioxins, then PCBs. They contribute, and sometimes there are many acids as well that causes.
Just curious, like dioxins and PCBs in wastewater?
Like sometimes if it is not regulated properly, at many places they enter into surrounding water bodies.
Any idea what's the source of these?
Not specific. As you can see here, then we have radioactive substances. Radioactive pollution happens when substances they emit radiation beyond their natural limit. And where does it come from? It comes from the production and testing of military weapons. Then there are some instruments that we use in our university and sometimes in hospitals as well. And if we just dispose them like without regulation and not improper setup, then it can cause many problems here. As you can see, it can affect the aquatic life as well. So what kind of water is being affected in this? Firstly, we have groundwater. As I told you about agriculture, it happens when pesticides and fertilizers, they from fields and sometimes from landfills as well, they slip into the ground and causes groundwater pollution. Then we have surface water. As I told you that rivers are being affected from sewage, then industrial waste. Then we have ocean water. It's same, like pollution that happens in river, it also goes into ocean, and also oil spills. Thank you.
If we take a break for 5-7 minutes or continue? Huh?
Is group only.
Okay, after this.
So I'm Kavya and I'm going to tell about geogenic pollutants. So generally everyone think that, most of the people think that the water pollution is a major cause because of all the activities which are done by humans. But there is also one more important thing which is responsible and influencing the water pollution are the geogenic pollutants. Geogenic pollutants are naturally occurring contaminants mostly found in water, underground water, due to some Earth's geological process happening. So they are totally not caused by humans. They have natural origin. They come from rocks, minerals and soil. And when water is flowing through the underground aquifers, these substances will be dissolved through the water-rock interactions happening. So as I already mentioned that this flow diagram is telling how the water is being polluted because of these substances. Like rainwater will be going to the underground, it will be absorbed by some of the rocks like granite, limestone. These minerals will be absorbed, will be traveling through some chemical reactions happening, and then the groundwater will be contaminated. So before going through this, we have to understand what is the study going on through this geogenic pollutants. So initially we'll be studying about the underground water flow as well, and the soil which are containing this all pollutants, and then we'll be collecting some of the samples in different water regions, and we'll be measuring some parameters like pH and TDS. And one quick question, do anyone know what is TDS? Yeah, that is total concentration
Again,
of
what?
Total results.
Anybody
Sorry.
can explain from first years what it is?
It's,
Huh?
it's the impurities or things present in water.
Carry on.
like it is the total concentration which is showing us the total concentration of insoluble substance like calcium, salts and all.
Insoluble?
Salts, solutes. And then we'll be also doing chemical analysis to find out what are the pollutants present and how much is the concentration in that particular water sample we have taken. And then we'll be also using GIS mapping for highlighting the areas which are having larger concentration beyond the safe limit. Like according to WHO, the safe limit for arsenic is greater than 10 microgram per liter, and for fluorine is greater than 1.5 microgram per liter. And it for example, mostly in India we are having more than 10 times or 15 times of this concentration level. These chemicals will be naturally occurring, concentration increases over time, and they will be also depending on the geological conditions happening and oxygen level, climate levels. This table will be telling us about what pollutant is present here and what is the source of them and what diseases they are causing. So there are 5 main characteristics of this geogenic pollutants. As I already said that they have natural origin, mostly in underground water. Let me tell you how they are dependent on the geological conditions. Like they will be mostly depend on alluvial sediments because like alluvial sediments will be having age differences, concentration differences and all. And if the age is lesser, oxygen levels will be produced and chemical reactions will be happening faster as possible. So the arsenic levels will be transferring fast and contamination will be fast.
Basically, simply if I have to say that these kind of rocks are much more reactive.
And they are hard to remove fully, but we can control it. They are also persistent. For example, like arsenic is mostly persistent in West Bengal. So in this, we have 3 parts. A part is telling us about the real world underground water flow, like the arsenic present in soil, how does it travel through rainwater and how does it contaminate and all. The B part is telling us the chemical analysis of arsenic, like how does it change from As+3 to As+5, reducing its toxic content based on the chemical conditions and oxygen level present.
Any idea by any chance which one is more toxic? AS plus 3 or plus 5 or both of them?
AS plus 3 is most toxic.
More toxic.
As the oxygen level and iron content is increasing, the arsenic content will be increased because of the rust formations. C part is showing us how in the microscopic, if we see through the microscopic, the arsenic will be either sticking to the soil or will be going to the underground water and contaminating.
Just one quick question to all of you. Anybody can explain what's adsorption and absorption? Just first raise your hand. Who knows how much? Full. पूरा हाथ उठाना है. And चलो ठीक है. एक let's hear an explanation. Gaurav start.
एब्जॉर्प्शन
जोर से.
सरफेस पे होना होता है एब्जॉर्प्शन, लाइक सरफेस पे जो पार्टिकल्स होते हैं उसके पे होता है एब्जॉर्प्शन होगा, लाइक पूरा बल्क में.
Mostly सही. Anybody else who knows it little bit better?
Sir, absorption is like going things inside the any particle, and absorbing is going.
Basically, whatever is the liquid portion solvent is integrated in the part of the body. Absorption. Adsorption is?
On the surface of.
Why does it get stick to the surface of any material?
Due to electrostatic forces and
Van der Waals forces.
wonderful.
Why did I ask? Because one of the potential ways to treat this kind of water, drinkable water, what do you use to treat? What is the product which you are using? Okay. In a bigger treatment facility, coagulation use. Okay. Any other?
RO.
RO is one. Another thing, which is a low cost one. Activated charcoal. So, for example, if you look into your AquaGuard filters, there is basically an activated carbon filter is there. So you pass the water through that, and it has capacity to absorb all these materials. That's why I was mentioning arsenic, fluoride. They are a big problem in our country. Continue.
And these are some maps which are showing. The first one is telling us the areas which are having higher content more than the safe limits. The B part is also showing similarly like different arsenic contaminant concentrations in different regions. The C part is telling us about, as I already mentioned, how it will be dependent on the alluvial sediments conditions, climatic conditions. The D part is telling how the concentration of arsenic is dependent on the iron concentration. The regions which are having iron concentrations higher will be also having arsenic contamination. So coming to India, most of the arsenic is present in Ganga basin, particularly West Bengal and Bihar. Fluoride in Rajasthan and Andhra Pradesh. These are affecting like millions of people in India. So we already know that these geogenic pollutants are dangerous because they are toxic and they can cause higher health diseases like cancer, fluorosis, and kidney diseases, like because of arsenic and uranium fluoride. They are very hard to detect because the water which is containing most of the concentration of these pollutants will be like mostly clean. We cannot look into them. Yeah, this is telling about the, as I before told, this is the total level which is shown. And yeah, there is a difference between the human-made pollutions and this. It will be detailed discussed by Ayushi later. And how can we prevent this? We cannot prevent or control this totally, but some of the extent we can control it by using some reverse osmosis as we already discussed, and some filtration techniques as well. For villages, we usually use some plants as we are using right now because due to the cost efficiency. Then we will find alternative sources for drinking water, avoid deep wells which are highly concentrated and all. So basically we have to treat and test the water every day, like frequently, so that we can identify the areas and not use them and treat it properly. Thank you.
Good. Just quick question to first years. What is RO? How does it work?
Like more than the
So, hello everyone, my name is Ayushi and I will be covering the topic of human-made pollutants, which is also known as enterogenic pollutants. So, onto the basic thing, what are human-made pollutants?
So these are the contaminants which introduce into the water body through human activities. In this pie chart, we can see the major sources of water pollution. The first and the major one is agricultural, followed by the industrial, then domestic, and then other factors. In this picture, we can also see the different sources of water pollution as well. So, unlike natural resources of water pollution, most of the human-made pollutant resources are identifiable and controllable. So, these are somewhat preventable. Why we have to focus on them? Because 80% of the global water pollution are because of human-made pollutants. So on the major things, so types of industrial pollutants, we can see that the heavy metals consist of more. Heavy metal consists of mercury, lead, cadmium, arsenics, which they obtain from mining and electroplating industries. Why they are harmful? Because they cause damage to nervous system. There is one case study of Minamata, Japan, where due to mercury discharge, many people fall victim to neurological disorders.
Can you tell a little bit more about how does it spread? Basically, a company was discharging into the water, fishes and the other animals, they started to accumulate it, and eventually the people. So eventually it's because of bioaccumulation.
The next one is organic chemicals. So organic solvents like benzene and toluene and persistent organic pollutants. So persistent organic pollutants are the toxic substance which resist natural degradation and they remain in environment for a longer period of time.
Any examples? Anything else? Very common. Pesticides, I did mention it in the class. One of the pesticides, DDT and all those. Do you know about what is DDT is? No worries, continue.
The next one is the thermal pollution. So when the industries release hot water into the water bodies, this creates a temperature imbalance and reduces the dissolved oxygen content and affect the marine life. The next one is acid and alkalis. This will cause the pH imbalance and affect the marine life, their reproduction cycle.
Why does thermal pollution decrease the DO level in the water?
So gases dissolving of gases are less in hot water.
Definitely, like the dissolution of oxygen, that is also reduced. Is there another factor?
टेम्परेचर ज़्यादा होता है तो माइक्रोबियल एक्टिविटी ज़्यादा होती है उसकी वजह से
लोकली DO डिप्लीशन ज़्यादा होता है. Good.
So the next is nowadays the technology has been increased and the uses of fertilizers and pesticides are also increased in the agricultural field. Here in this chart we can see that the global pesticide use is increasing over the pesticide mainly consists of DDT, ethylene and glyphosate. So these undergo biomagnification and
what is biomagnification?
So they remain in.
They start accumulating in the body. Any animal or fish is consuming them, it started to accumulate in their body.
And as the food chain goes higher up, they.
Explain it a little bit more, but ठीक है, चलो.
The next is excess nitrogen and phosphorus. So these trigger eutrophication, which lead to algal bloom and aquatic diet salts. The next is livestock waste. So organic waste material from the farms. These may contain pathogens which enters the water body and causes diseases like they contain E. coli, salmonella, and ammonia and contaminate. So we can see that the agricultural field use major of the water. The next is untreated sewage. So it contains pathogens, pharmaceutical drugs, detergents, which lead to the waterborne diseases like cholera, typhoid. And why we need to focus on this? Because in India itself, it produces a lot of sewage on a daily basis, but only 37% of it is treated. The next is the microplastic, so plastic materials which are less than 5 mm. So they have been detected in human and marine life as well. And the major sources of microplastics are synthetic textile, tire dust, city dust, and mainly urban and road runoff. And why it is important? Because the about 8 billion of global population is affected by microplastics. The next is oil spills. So when the crude oil or the petroleum spills on the ocean and they form a thin layer of oil on it, known as oil slick. This blocks the direct sunlight entering in the ocean, and this also reduces the dissolved oxygen content in it, and this also causes carcinogenic. This also release carcinogenic pH. pH are polycyclic aromatic hydrocarbon. The image you can see is the different sources and the results and effect on human health.
Some of the organics which are present in these oil compounds, they are carcinogens. Okay. Continue.
The next is the road runoff. So they also consist of heavy metals, fuel residues, rock salts like.
Why are road runoffs contain heavy metals?
So like the tire dust and all.
So I mean either tire is containing heavy metals, or anything else is also containing heavy metals. Do you read it somewhere?
Ash from the coal, the fly ash.
No, but it's about road runoff.
It will settle on the road.
Yeah, okay. It's close to the coal power plants, I can agree. But what about the other places? Teammates.
Construction.
Maybe asphalt maybe containing.
Maybe, or have you checked? I mean, read about these kind of stuff. I mean, that's important. Chalo, continue.
And the next one is radioactive waste, which contains cesium and strontium, which remain in the environment for a longer period of time and they cause cancer and genetic
Nice one.
Hello everyone, I am Anshika. So let's talk about the effects and prevention for the water pollution. Some slides are missing.
Okay, let's take a break for 5-7 minutes.
Hello everyone, I am Anshika. So let's talk about the effects and prevention for the water pollution. So yeah, human health effect. Due to unsafe water drinking and like wash use, sanitations and hygiene, there are like 8 lakh and 9,000 deaths annually. It's a global data, and 1.7 billion people are at risk because they use contaminated with human and animal species, and 5 lakh and 5,000 people are dying due to diarrhea. And these are the diseases which are causing due to drinking of or using wastewater or polluted water, like cholera, typhoid, diarrhea, dysentery, and HIV and polio. Example, pollution in Yamuna River has led to toxic foam formation in Delhi, and people exposed to this water suffer from skin infections, respiratory issues, and health risks. Moving forward, long-term exposure to this polluted water can lead to cancer, organ damage, and like kidney or liver damage. One of the example is Flint water crisis, which was happened in USA around 2014. It was basically toxic water can cause permanent brain damage in children. This was happened due to like the untreated water from the river caused lead contamination in Flint and Michigan, exposing thousands, especially children, to serious health issues. They directly using the water from the river, and that caused the brain damage for the basically for especially for the children's.
What location? What location?
USA.
Where in USA? USA is big, right?
Flint. Flint is the location.
India, Michigan.
Michigan. And 3 children under age 5 die every year due to unsafe water drinking, according to United Nations organizations. And weak immunity. Young children are far more vulnerable to waterborne infections. Consequences include malnutrition, stroke, physical growth, and impaired brain development. Like the example of Flint. Environmental impact, loss of biodiversity with the animal, like we see like animal are drinking unpolluted polluted water because there is no option for them, like they can't get the fresh water, like and due to this diseases and organ damage, and that happens as in human. Fish deaths in river like Ganga river due to industrial waste, marine animals mistake plastic food for, causes leads to death, and toxic substances move through the food chain, which is called bioaccumulation. Aquatic life, reduced dissolved oxygen in the marine life causes
Part
that.
of it we have already discussed, right?
Yeah.
So go to the new stuff.
I want to discuss about the Gulf of Mexico
Yeah,
example.
that you
like,
can mention.
low oxygen zones make it impossible for marine life. What happened that is like eutrophication, basically algal blooms happen in Gulf of Mexico. And this is a graph we can observe, India show a higher number of deaths compared to developed nations. What are the reasons behind it? Like maybe people are limited access of safe water, like people from rural areas or slums, they can't get even a safe water for drinking. And awareness also, like sometime before there was a Instagram reel which is going viral, like that people is diverting milk to the Ganga river, which was completely like a foolish kind of thing.
Okay. And they are putting what they are putting into the river?
Milk in the Ganga river.
How does it gonna affect the water?
Milk have microorganisms to loss of oxygen. They consume oxygen, so
Basically, they would reduce the DO of the water.
Yeah.
Okay. Anything else?
Yeah. Milk have many bacteria or like.
They have bacteria, but are they harmful for the water or beings who are living in there?
For biodegrading them, they consume oxygen basically.
One is DO is reducing. That's one problem. Anything else? Very obvious. Turbidity.
Turbidity. But in the river, we are there.
Instead of turbidity, I should say that it's river water. If the concentrated part is mixing there, and if it's mixed in a very high amount, significant amount, it is gonna block the sunlight and other stuff, right? And it's also degrade into the products which could be more acidic, could be toxic depending on the bacteria. Think about that stuff when you are presenting. Okay.
But the river is large, so.
Well, if river is large, then why is the issue?
It's an issue. Yeah. Okay, good.
Continue.
And economic cost and treatment. Economic impact: increase healthcare cost, loss, agriculture efficiency billions, productivity billions lost annually, and wastewater treatment: treat sewage before release, remove harmful chemical bacteria up to 99% contaminants. And why we can treat water, like it's a more cost efficient method, like whether if we are dealing with the long term impact, it would be like it would not beneficial for us for cost effectiveness. Industrial and agricultural solutions. So yeah, this map shows the higher like wastewater treated across countries. Globally, we are treating like 56% of wastewater, and in India, we are treating only 28% of it. And industrial control treat industrial waste properly, reduce toxic chemical discharge, policy regulations, agriculture solution, reduce fertilization, pesticides, use organic farming, prevent runoff into the water bodies. In some areas, agriculture contribute up to 70% of wastewater. Like we can say in Haryana, because Haryana is the major source of like producing agriculture. Waste management, proper disposal of garbage, improve sewage system, and reduce plastic pollution.
Are you there in the morning today? That's the partly I just discussed in the morning class. Okay, just wrap it up quickly and let's go for the next one.
Advanced treatment technologies like membrane filtration, reverse osmosis, UV purification, and wastewater recycle, reduce, bioremediation. It's use of microorganisms to clean polluted water. Basically, they are absorbing the like oil is a pollution for the water. By using microbes or plants, they can absorb that oil from the water. And individual actions and government role, which
not just absorb, they convert the product into something else which is less dangerous. Not just absorption.
After the absorption.
What are your portion?
For plants, I didn't microbes. Are they converting?
I think I was one who's supposed to ask. You are the one who is presenting. Alright, chalo, koi baat nahi. Continue.
I did, but
No worries. Continue.
launch public awareness campaigns like that Instagram reels. Devotion is not about devoting. And sustainable solution for tomorrow, rainwater harvesting, water reuse, conservation, eco-friendly practices, and efficient water reuse. And these are the resources which I got done. Thank you.
Hello everyone, my name is Saeed and I am presenting a case study on Singapore's hydrological model. So, water is a really important resource for a country, and like every country wants to maintain water security for its people. We'll study what's the Singapore's model about this urban water resilience. So there are four national taps in the Singapore's whole country. The first one is storm water, which is the rainwater. The second one is the desalinated water. The third one is recycled water, and the fourth one is to buy water from another country like Malaysia. So one other key component is how they manage the rainwater. So they consider the whole island of Singapore as one catchment, and as you know, like catchment is designed a certain way that the whole water of whole rainwater gets collected in a certain reservoir. So that's the storm water and the wastewater. Wastewater, they use DTSS system, which is basically deep tunnel sewage system, which connects the whole Singapore's wastewater into a singular waste management or sewage treatment plant. The next thing is water balance equation, which is PQ is equal to Q plus ET plus delta S. So this is nothing, we can say in a particular region, whatever is the water content entering the location will be the water exiting it. So based on that, P is the precipitation of the water, how much water rainfall is there, Q is the surface runoff, ET is the evaporation, and delta S is the water stored in the soil. So these are the four components. But what urbanization does is it transfers ET, the evaporation, to Q, which is the runoff, because the urbanization causes urban infrastructure, which is like cement roads and all, which causes this coefficient of Q2 raise, which causes Q2 raise and ET to lessen. So we as engineer can develop certain solution to increase delta S in order to restore the equilibrium. So we'll see how we can do that. What Singapore does is it consider a 50-year return period rainfall and have made all the tunnels and like drainage system based on that, all the major ones. To calculate how much is the Q peak, the surface runoff peak, they use this formula, which is a very traditional rational formula. C is the coefficient of runoff, I is the intensity, and A is the catchment area. Intensity can be calculated via this particular graph, which is like based on rainfall intensity versus the duration, and we consider the 50-year return period. 50-year return period basically means it has 2% probability for that particular year to have rainfall of such intensity.
Just one question. When we are designing hydraulic structures, what's the design period we are roughly taking? Any idea?
For India?
Yeah.
I don't know about India. Like there is no specific thing. We if we design for smaller things, we take 10 years return period. But if we design for a like whole city major drainage, we take larger periods like 50 and 100 years. So the next system is marina barrage system, which is basically the whole land area is just an island, and there can be a situation where the runoff is really high and there is a high tide in the ocean as well. So at that point of time, the surface runoff will be on the surface of the land only, which will cause flooding. To prevent that, they have made this barrage system, which is having a dam for ocean or sea, which is basically they have 7 turbines and when there is a case of high tide and heavy surface runoff, they turn on this turbine, which causes the inland water to go into the sea. But it also prevents that the sea water doesn't come onto the land. The next thing is new water system. So I believe like any of my teammates would have covered the treatment of water. So after that treatment, getting a secondary effluent, we get this secondary effluent, which is basically treated like waste treated, basic waste treated. After that, we have this whole system where the two major part is the microfiltration and the reverse osmosis. Microfiltration is it works on the like micrometer scale and filter out any particle, suspended particle on the water. And then reverse osmosis, which is basically we have studied how reverse osmosis works. It's like a semi-permeable membrane which allows the water to pass through. So based on that, they create a new water, and around like 40% of whole Singapore uses this new water only. After that, yeah. So what is the technology they are using? As earlier they are using the like general semi-permeable membrane, but one issue is that in that one the membrane we use is like really thick, which causes heavy energy. But there is research going on making a graphene-based like membrane, which can be easily engineered to make nanometer scale holes, and since it will be really thin, because graphene is can be thin and made certain kind of holes, so the energy flux we need would be much lesser. So that's another thing. And the last thing is an initiative by Singapore government is ABC Waters, which basically activity, beautiful and cleaning. So which is to make general urban water reservoirs or lakes into a recreational area, which is beautiful and does help in cleaning. How does it help in cleaning? Is using basic principles like they make catchments, and catchment is like filled with grasses and all. So whenever there is rainfall, the rain will go into the catchment, and due to the plants and grass, it will catch some pollutant. That's one kind of thing. The other kind of thing could be a wetland, artificial wetland system, which is basically a wetland. I believe you must know what is wetland is. So they have like pipelines beneath that, and they collect the water from there to main reservoir, and that's the actual collecting of.
Basically, wetland is more of a cleaning mechanism.
Like they use as a cleaning mechanism in here. So this is a picture of Beeson Park and Singapore itself. You can see how they have made it serve all the three purposes. Yeah, the conclusion part. So like India can also have it, but given the large area of India, we can't have a whole country as a centralized system. We can have decentralized city-wise certain planning, which will allow the whole water in the particular city to revolve in one cycle only. And that's pretty much it. Thank you.
Good evening all. I am Animesh. I will be presenting the case study of Sumit. On the way of Sumit. So you must have heard the lake, Bellandu Lake. It is a lake in Bengaluru, and it is one of the largest lake in the city. But actually, it has converted into one of the most polluted lake in India. So some of the interesting shocking facts you will know about that the toxic foam which is occurring on the surface of the lake is being spilled into the road, and also it has caught fire. Yeah, this is very shocking that fire over the lake. So let's know the timeline that in 15, 16, 17, 18, 19, 21, in all the years the fire has been over the surface of the lake. And this is a map showing that from where the inputs are being into the lake. Like if you see, this is a map in Google Earth Pro. You will see here is a STP, and at that location there are some STPs which are used to treat the sewage water. But if you will see in the next slide that 260 mld of water from the Bengaluru is being dumped into both the lake Bellandur as well as Varthal lake, and they all are connected actually from the drainage system. And the important thing is that most of the sewage water, that domestic sewage water, is directly dumped into the lake without being treated, because there are some existing STBs are there, but also there is some STBs are being constructed because the number were not matching the numbers of input and the output. So
basically all the wastewater which is coming in,
yeah,
it's not completely got treated, only
yeah,
partly is treated.
Partly is treated.
Okay.
And if you see that these are showing that the sources which are without being treated dumped into the lake, and also you will see that proposed PS, that the pump stations are there, that which are burning the water from the lower elevation to the higher elevation of Bellandur Lake. So basically they are dumping the water from all over the city to these lakes.
Just to be clarify, like there are smaller lakes,
yeah,
where it's get accumulated, and then they are using the pumps to deliver water.
No, like some of the drainage wastewater, they are in the lower elevation area, and the lake is in the higher elevation area.
So basically they are pumping it.
They are also pumping dump that water.
And who are doing this pumping? Industry or government?
Yeah, industrial most of them. And also if you will see that the most culprit is the untreated domestic sewage water, and also there are some cases of oil and grease and this hydrocarbon coming from the garages, because they are well connected through drains, that roads, and also heavy amount of solid waste and plastic are being dumped into the drain, and ultimately it falls into the lake. So at the end, what happens? Why did it caught fire? Due to the toxic gases, it is evolving from the a high amount of BOD in the lake, and from that we know that methane gas is emerging from that organic waste, and these oil and grease, they are helping in combustion. So this is the main reason it caught fire. These are some sources he has used, and also like the main problem is the toxic gas emerging from that, and also that a large amount of water, like if I had read an article that less than 1 ml of water in the lake is pure. So this shows that how much polluted it is in an article in Times of India. You can search through it. And this is showing that how much polluted have been the lake water. And if you get contacted, you will get all these diseases in free. And also there are some implementation doing to here that National Green Tribunal. You must have heard that term, that heard that institution which is taking orders to close these polluting industries.
These are the audience.
Yeah. So to close the polluting industries. But some of them has closed, but not the all. And also, I have shown that in the map there are some STPs being constructed now. And also, you must have seen there are some NGOs which are working to clean the surface, like clean the solid waste at least. So this is all about the lake. Let's come to the geogenic pollution.
पढ़ लेना ढंग से वाली केस स्टडी आ रही है क्वेश्चन पढ़ के ठीक है.
And my friend Kavya has already described about the geogenic pollution, but I will focus on the three types of geogenic pollutants like arsenic, fluoride, and uranium. Why I have chosen this? Because they three are somewhat different from each other. How they are being come into groundwater sources. If you will see that arsenic, this is a type of geogenic pollutant which will affect your health if it exceeds the set limit. Okay. So it is not a particular case of India, it is actually a worldwide problem. You can see that this map is showing that how much affected all the continents are and what are the major source of this arsenic pollution. You will see that mining is a major source in Asia and also some part of India, but and I will see that here you will see that the arsenic hotspots, that the contaminant hotspots along the this Gangetic plain and also along the Brahmaputra plain. So we'll see why these are concentrated in that region. If you will see that why these are happening, most of the geogenic pollutants are due to weathering or leaching of the rocks, but they are little bit different from each other. And if you will see that 50 million people are in the high risk zones. Why? Because these are the plains, like the Gangetic plains are the highly dense population is living there. So that's why the number is so much big. If you see that I have tried to explain that the arsenic 3 is a highly mobile. Why? Due to the 3 plus charge. And what happens, I have in the previous slide, I have seen that dissolution of iron coatings. Okay, so these are absorbed on the surface of the iron ferric oxides. So once it is absorbed, it goes when deeper to the in absence of oxygen, some microbes turn the arsenic 5 into arsenic 3. So this is the process of arsenic. But you will see that in the case of geogenic pollutant, three major factors play the role. That first is aquifer geometry, second is lithology, and third is the flow regime. Here in the map I have
what is lithology?
Lithology.
What is that?
The study of rocks, like the compositions. What are the litho means rocks. So study of rocks is lithology.
What is the composition and how they are compacted?
How they are formed, like how many types of rocks are there, how they have been formed through years. So in this map I have tried to explain that how the flow regime is affecting the concentration of arsenic. And you will see this is the map of iron distribution, and you will see the direct correlation, because I have explained that how does the ferric oxide plays the role. So in case of a Semria Ojapatti village, because this village you must have not heard about this village, but this is very unique, because you will see that this is the region of Bangladesh. So here the Gangetic river mixes with the Bay of Bengal, and so it is widely various. So there is a very much plain. But from that point of view, the village has higher than this concentration is higher than the that average concentration of arsenic you will find in Bangladesh. Why? Because I have explained the three factors. What happens that the aquifer geometry, what happens whenever your water table, water level depth is higher than the the river level, so what happens, the groundwater flows to the river, but when it reverses, the water from the river flows into the groundwater. So that's why that's how the contamination takes place. That whenever the river is flowing, it is accumulating those arsenic pollutants through it, and whenever the ground level difference is there, they are percolating into the groundwater. So that is aquifer geometry. And if the river through which it flows, it contains these type of pollutants, then it is a higher chance. So this is the major case study, because by this, in the shallow depths of the groundwater, they are extracting. That's why the concentration is so much high. So why shallow? Because they are near to the tributaries of the Gangetic rivers. And these are some effects, health effects. And the thing which you need to note, that these arsenic are very high affinity with proteins, lipids, and other cellular parts from which we are made. So it is very high chance that it will not only affect the skin, or means it can distribute through your whole body, and it can affect your brain and nervous system, liver, lungs, all the things. Then coming to fluoride. Fluoride is also harmful if it exceeds the safe limit, that is 1.5 milligram per liter. And the primary sources are geogenic sources like fluorospar, apatite. Sometimes you will see the direct element in like CF2, but sometimes it is as a contaminant in the rocks or minerals. Like rocks or minerals like granite, gneiss. These are metamorphic rocks. So sometimes also farming also leading to the like phosphatic fertilizers. These are also leading to somewhat extent of fluoride contamination.
How the farming part is contributing there?
Sir, there may be concentration of some fluoride in the organic manure you are using.
Okay, so basically water, the fluoride is going into the manure, and the
Yeah.
manure you are using on the ground.
And that.
Okay, that goes into the soil and also goes into the runoff as well.
Yeah.
Okay, that's one thing. And what is metamorphic rocks?
Metamorphic rocks means they are very aged rocks, like they are pressed for higher time, higher extent, I will say. Like metamorphosis, we mean that the change of the structure of the rocks due to high pressure and high pressure and high temperature.
Got it.
So also there is a certain you will see that low calcium levels is a indicator of that your fluoride contamination is high. And if you see through the India map, these arid regions are very much affected due to the fluoride concentration. Why? Because in these regions the groundwater availability is low. So once it penetrates very much deeply, I will explain it in the next slide. Once it penetrates very much deeply, it is being contact with these type of rocks in a higher extent of time. So this leads to the higher concentration of the fluoride. So as much depth your water goes, it is high contact with those type of rocks. So
another way of saying that, so if your groundwater table is going down,
yeah,
and you are extracting more water, there is higher chances
of fluoride contamination in that water. Yeah, and also that after this lithology, like composition, the third thing is rainfall. How rainfall? As I connected these rivers and the groundwater, same thing happens. If you will see in the pre-monsoon, this is the pre-monsoon data and this is the post-monsoon data. If you will see in the pre-monsoon data, these are very arid regions, Jaisalmer, Nagaur, Dhammatri, Barmer. But if you will in the post-monsoon, the graph totally changes, because these rainfall also affect, because once it rainfalls in a heavy amount after the monsoon, what happens? There is a certain amount of river like fill up the rivers. So once the river fills, actually we know that why aquifer, how does the aquifer works, that the percolation time very much decreases in the aquifers. Like there are certain places where your groundwater rechargation rate is fast. So if in that regions, what happens, the concentration decreases once it rains. So this is how rainfall is affecting. So this is I am showing that like in some cases you will see higher fluoride concentration, but most of the cases, as much deep you are going, your fluoride concentration is increased. Some cases it is so because I explained that there are three major factors. You will see that how much depth you are going, though your fluoride concentration will be higher. And there is a dual nature of fluoride. It is also needed. Like this is for as per your body weight, it is indicated. And if it is taken in higher amount, it can lead to dental fluorosis or skeletal fluorosis or non-skeletal fluorosis. Then a very important case study, a very new case study I have heard, that uranium, and you will like a shock to know that 12 Indian states are above the safe limit. Like it is very much dangerous, and it is a radioactive material which is found in our groundwater. What can be more harmful than that? And if you see in the cases of Punjab region, it is come to 532 parts per billion when your safe limit is at 30 parts per billion. And I have derived this data from downearth.org.in. In a video they have showed this data, and you will see like 29% of the wells are affected. And if you will see that how this happen, that once you go deep through the groundwater, so what happens? The groundwater tries to come up. So there is a mix between the shallow depth groundwater and the shallow groundwater and depth groundwater. So once this mixes, these types of minerals, they are in very ionized form. They oxidize, and that's how they come into the our groundwater, shallow depth groundwater sources.
So if I understand it correctly, they are generally in the lower part of, like especially in the depth of the groundwater.
Yeah.
But when the opportunity arises, they mixes
oxidized and they come into the groundwater.
And just
So
one thing, explain it to the for the class so they understand how much is a ppb is unit, parts per billion. How much is the unit is? Because there is one term which is called parts per million. It's 10 to the power minus
6
billion
minus 9.
Yeah. So
Plus 1 part per 10 to the 9. Yeah.
So even at such a small concentration, what is 10 to the power minus 9 is? It took centuries to us to develop an instrument which can detect such a fine concentration, and even at such lower levels, it is causing these kind of health issues. So that is an important area to work into.
So the safe factor is it can easily remove through urine and feces, but the thing is it is radioactive. Once it gets into your body, there is higher chances of cancer, and like your maybe in kidney cancer or something like that. So let's come into the hard water. Like also hard water is have a limit that if it is 121 to 180 limit, it is hard water, and if it exceeds 180 mg/L, then it is very much hard water.
What exceeds? What is the thing?
Concentration, it is measured in the concentration of calcium carbonate, because mostly the hard water, 2/3 of the concentration is perceived by calcium, and 1/3 is by Mg2+. So how do we test it? We generally precipitate it. So from that we know that how much mgl of calcium carbonate is.
Basically, that's the concentration of calcium carbonate.
Calcium carbonate. Yeah, means this is a secondary test, we can say. So there are two types: temporary hardness, permanent hardness. You must have read about in the schools, like heating breaks down the HCO3 compound.
Pada school?
Continue. Yeah, and the same thing is the primary sources are the groundwater, extracted from borewells or tube wells, and the high risk state are like Rajasthan, Haryana, Karnataka, where the major source is like groundwater source based. So if you will see what are the daily life, how much it is affecting, like you will see it will form that layer of scale build up, because there is calcium and magnesium, they form precipitate, and like carbonate precipitate, and they get that's why called lime scale build up also, and they get precipitated over and over. So this leads to, we need to, like, they clogs actually. After some time it will clog, so we need more power to pump. Yeah, that's one thing. And second thing, we all are facing those hair falls. Why? Because these are forming small precipitates over these, and this leads to fungal growth or different types of. And third thing is that in laundry cases, must have been feel like the fiber is very hard after, like feels very stiff after. So these are the effects of this hard water. And also you must have seen soaps come like, yeah. So also the soft water, like soft water is a case that very low concentration calcium magnesium, and if you drink it, so there is a chance that you may miss these calcium and magnesium, which are also important for our health. And also these are naturally available sometimes, but also we have to make it artificially. So there in the artificial makeup, the concentration of sodium is high, and in a case study of US, Europe and Japan, this is not proven, but there is a something correlation between the cardiovascular diseases and consumption of soft water. And also the thing is that I want to enforce you that once you boil the soft water, it actually the time between soft water and hard water boiling is same. But the thing is that in the industrial scale, when they are heating the water, there is scale build-up. So it reduces the efficient heating of the water. So in a large scale, you can say that the soft water is beneficial for heating purposes. So that's all from my side. Thank you.
So good evening, I am Palak and my topic is ocean pollution. We have studied about the effects of pollution on land and agriculture and stuff on humans, but now we'll look at its first outputs on marine biodiversity. So firstly, what are the sources of pollutants in ocean? First is sewage and agricultural runoff. Secondly, plastics, oil spillage. There are industrial waste coming into oceans. There are hard metals, heavy metals coming into oceans. But I'll mostly focus on the first two parts. So firstly, let's study about sewage discharge. So every year, 6.2 teragrams, that is 6.2 million tons of nitrogen comes into ocean, and the study was done on 130,000 watersheds, and it was found that only 25 watersheds contribute to around 50% of all the nitrogen in this area. The nitrogen here consists of all the nitrogen oxides and ammonia and stuff. So as you can see in this graph, in India and China, mostly the sewage which is discharged is untreated, whereas in United States mostly it is treated. So of 25 of these major watersheds, mostly are in India and China, and the Yangtze River in China contributes to 11% of this 6.2 million tons. Now, what are the effects of these emissions? So, firstly, if this much nitrogen is going into ocean, it leads to excessive nutrients, which leads to eutrophication, that is formation of algal blooms all over the ocean surface. So it reduces the sunlight penetration, and also it reduces the dissolved oxygen levels, which is harmful for marine biodiversity. And also 58% of global coral reefs and 88% of seagrass beds are exposed to this. Coral reefs and seagrass beds are major biodiversity hubs. Also seagrass beds are they absorb huge amount of carbon dioxide, so it is at huge risk. This is a map of algal blooms all over the world in 2023. You can see that most of the algal blooms are at the coastal areas. So sewage is more in coastal areas, so there is a direct correlation.
Sewage is more in the coastal areas now.
I mean, more population is there, so more discharge is in city areas, urban areas. Now let's look at plastics. So 8 million tons of plastic waste enters into the ocean every year, and the major sources of it are rivers, which at the end up into oceans. Secondly are via beaches through tourism and stuff. Thirdly is fishing gas. fishing nets and all. So this is the Great Pacific Garbage Patch near California. It is the size, twice the size of France, so you can imagine the scale. Here, due to the ocean currents, all the plastic from ocean ends up over here, and it leads to creation of a dead zone under it. In all of the earth, there are majorly 4 to 5 dead zones, which are this big in size. This is the biggest.
मॉर्निंग में थर्ड क्लास में
So what are the effects of these pollutants? Firstly, the animals get entangled in this. Secondly, these get into food chain and bioaccumulation, and overall human also get affected. Thirdly, there is a thing like we only see the plastic which is on surface, but around 35% of plastic is more denser than water, and it gets to the seabed, and all the plants and stuff inside the ocean are also exposed to this.
Basically, part of it is going into the sediments as well.
Yes, that's it.
Good.
So now we will do river pollution analysis, and our topic is Prayagraj. So Prayagraj का पहला नाम क्या था? इलाहाबाद. तो इलाहाबाद ही क्या? The main reason is Ganga जो flow करती है, it flows from around 100 plus cities. So here is a map of Ganga, then Yamuna. So it consists of around 100 plus cities, and the special thing is Delhi, which covers only 2% of the river length, contributes 80% to the pollution of river. So here we can see around over here Agra, Delhi. So this part contributes around 80% to the river pollution at Prayagraj. What are the major reasons for pollution? Kumbh Mela, because of this dissolved oxygen drops by 5.1 milligram per liter domestic waste, industrial discharge, etc. So dissolved oxygen ज़्यादा होना चाहिए, कम होना चाहिए? ज़्यादा होना चाहिए. क्यों? क्योंकि बायोडाइवर्सिटी को हेल्प करता है. During Kumbh Mela, so the amount of dissolved oxygen drops on a massive level, which hampers the biodiversity in the river. What impacts it creates? Main impact is pathogens. So around like several pathogen exposures, and which affects water bodies, and in general biodiversity is affected, and the health of general public is affected. Waterborne diseases, heavy metals, then ecosystem and economic losses. Then what government does for this, which in short we will discuss the circular water economy. Main are three things. Reuse of water, ZLD. What is ZLD? Zero liquid discharge. We will discuss what is it. And industrial compliances. What visions government hold is India. So 20% reuse by 2025, and this slides में थोड़ी ऐसे ये है. So what is zero liquid discharge? The amount of water you use and you dump is zero. So means is kind of equal. So which is meant by you do not dispose any of the garbage into rivers and water bodies. Another thing is government provides water credits. What is this? If you use your own dumped water, your own waste water, the government credits you that you do not put pollution into rivers, and government subsidize for it. So what are the government policies and financial benefits? One is that credits, water credits. Another is zero liquid discharge adoptions. Another is municipal revenue potential. So if the industries provide substantial water neutral. So what is water neutral thing? Water neutral thing is the water used is equal to water saved, water reused, or water replenished. So here comes as what are environmental outcomes by this government policies. One of the most important project is Ganga Yamuna and Namami Gange. So what those have created, they just improve the dissolved oxygen levels in the river and improve the river health. Another is reduce groundwater extraction, as the industries are using their own wastewater or their own dumped water, which in general restores the ecosystem. Other things, sustainable management. Then what are the future projections? This is the more accurate data. India as a target 50% reuse of industrial water waste by 2030, and yes, water neutral growth model. In conclusion, government policies and engineering are to transform wastewater from liability to economic assets. This was it. Links with it, but
Okay, so far we have understood, or I hope that you guys have understood that why water safety is necessary. But let us now understand. How do we ensure this safety, and what are the underlying approaches that we implement for this safety. Okay, so I guess the slide was done. Okay, I'll just explain it by myself.
It's fine. Just explain it.
So earlier what used to happen that after we used to treat water and then after we used to test it. Okay. Yeah,
you can just present what you remember, it's fine. Continue.
So what this has a major limitation to it, that if contamination is found in water after treatment, we have no way of prevention. So basically the complete process happens and then you have identified the problem. So instead we shift our mindset and then apply the then we shift our mindset to test the water at different stages. So during the whole supply chain, starting from the source to the end consumer, we test the water and look for possible risks. Now, as I say, test the water, let us also look at WHO's framework that how should we test this water. Firstly, we set health-based target. Why only health-based targets? Like we can lay mathematical computations and scientific principles to test the quality of water, but at the end of the day, what do we want? We want the water to be safe for us to drink. So that is why health-based targets are necessary. Then educate systems to test this. Now let us take an example of Chernobyl that sir has also mentioned in class. What happened in Chernobyl? The device that measured the radiations in Chernobyl had a limit up to which it can measure, and that was under the safe measurements, and people thought it is safe, but we all know what happened. It was disastrous. So inadequate systems can lead to disasters, and then surveillance should also be dependent on some outside source. Like obviously we cannot trust the operators themselves to say that okay, my water treatment is.
You need a continuous surveillance at different steps. Okay.
Now, okay, so we'll also look at this later. But first, I want to show that is from site visit that I have done in a course that Sudhi sir has taken. You can also take this course. Just don't drop it. So it was a annex building that you can see is basically a supporting building that has it is separate from the main cleaning aeration that will.
Where's the location?
I don't exactly remember it now.
Near in Gandhinagar?
Yeah, it is near Gandhinagar. So it is basically different from the main process of water treatment, but there are several processes that are carried in this. For example, population, filtration, etc. Chlorination that we'll also discuss later in the series is done image, the second image is basically sedimentation or process. Now, the key components of water safety plan, or how do we ensure, like there were the philosophies that we talked, our mindset and all. Now let us look how do we implement those things. Firstly, we evaluate the entire system. So basically, complete from source. Now by source I mean rivers, groundwater, or sometimes even wastewater that we'll also look at. And then look for vulnerable sources for contamination, like where contamination can occur or can pass through our water treatment in the process. And then obviously, since we have identified the vulnerable spot, we implement,
we take action
actions accordingly. Now this is not one time process, we need a continuous operational monitoring, because see, wastewater treatment plants are used and we cannot guarantee the safety by one time. So we need continuous monitoring. And then we have management plans as well. So for example, what happens if a factory has dumped a lot of waste in liver, that is our source. So we need quick actions to be taken, and therefore we have all those plans in our measurement. And then adaptability is also one issue, that wastewater treatment should
adapt to the new
problems. For example, the river one that I mentioned. So
if I have to just go back, so if I have to summarize it, first you will identify where your water is coming on. Second thing, you will identify what are the potential sources which can contaminate the water. That's number 2. At the same time, you are monitoring at every step. And let's say if someone is breaking the laws and creating a problem, you have also a specific plan of action what to do in those kind of situations. That's all right.
Now, before we study not just India's, Asia's largest water treatment plant that is situated in Mumbai, Mandu water treatment plant, I think we should ignore the fact that 52% of people in Mumbai don't have access to clean drinking water. And this is the place where largest water treatment plant is situated. But let us look at how does it function. So these are all data that I guess you can look up to if you have time. But yeah, so what are the sources? I guess it is important, like Modak, Sagar, Tansa and Parsa.
These are the reservoirs where the water is coming.
Yeah.
Okay.
And then I guess what is more important is the next slide. It is the process that happens. So let us understand what happens overall. So firstly, we treat the water with pre-chlorination. So it kills all the pathogens present in water. And why is killing them necessary? You can also see post-chlorination. So why not just one time? Because this ensures that further processes are done safely, and also killing pathogens early stage reduces the UV. So
are you sure that's the only reason for putting pre-chlorination in the beginning? See, pathogens, for example, if they are passing by, they can always be killed in the last process as well. Why to introduce pre-chlorination in the one step as well?
Do not disturb the other processes.
How pathogens are disturbing other processes? Just curious.
I guess in aeration what happens is we supply oxygen. So I guess since bacteria and all also consume that oxygen, that can be disturbed. This is what I think. I am not.
Actually, that's what I am mentioning. That's not the only reason. And don't feel bad. I made the same mistakes because honestly, when you read, okay, I'm just taking a little bit more time because this is important. That's the same process which is applied to our campus as well. And when I came to the campus, I was just wondering like why do they are putting pre-chlorination in the beginning? Pathogen is not the main concern. It is a concern definitely. That's why you are having a post-chlorination. and you will all add residual chlorine as well. So your whole supply line, there will be no pathogens will gonna affect you. But pre-chlorination is also done because lots of algae and some of these organic compounds are coming into the, and if you are not removing them, then they will affect a lot of in your coagulation process. So pathogen, when you are talking about, it's specifically related to the microbes, not the algae and these kind of compounds. But otherwise, it's correct. Continue.
So now the next process is aeration. As I already mentioned, we pass oxygen to remove gases like carbon dioxide, hydrogen sulfide. So hydrogen sulfide is the main cause that.
Basically, the volatile compounds, volatile organic compounds, they got removed in the aeration.
But how does this oxygen remove these gases? Like, for example, as I mentioned, CO2. CO2 does not react with oxygen. So what happens exactly? Does anyone want to answer?
Try karo, come on. First, 1 second. What's the question is asked? Then that's a better question. Again, repeat the question.
So, like, we pass oxygen to remove gases like carbon dioxide, but oxygen does not react with carbon dioxide. So, what happens? Like, how does it remove it?
Anybody? Any second years also? Some of you are taking the course. Wait, continue.
So,
जोर से हाँ come on continue करो.
So basically कार्बन डाइऑक्साइड जो है वो एटमॉस्फेयर में कम होता है. So जब हम ऑक्सीजन पास करते हैं, so हेनरीज लॉ के अकॉर्डिंग जो पार्शियल प्रेशर होता है वो, क्योंकि कार्बन डाइऑक्साइड का एटमॉस्फेयर में कम होता है तो वो एटमॉस्फेयर में रिलीज हो जाती है. हाइड्रोजन सल्फाइड जो थी वो तो रिएक्ट ही कर जाती है और सल्फेट सल्फर बन जाता है, तो वो सॉलिड फॉर्म में आ जाता है. Then we have coagulation. So coagulation is basically हम नेगेटिव चार्ज जो होता है वो एक्वायर करवा देते हैं PPTs पे, और वो लाइट चार्जेस होते हैं इसलिए रिपेल करते हैं, तो अल्टीमेटली वो सेटल हो जाता है. एंड एक फ्लोक्यूलेशन और सेडिमेंटेशन वाला मिसिंग है इसमें. बट हाँ, फ्लोक्यूलेशन
थोड़ा लग रहा है मुझे किसी ने कोर्स ड्रॉप किया है ये वाला. चल कंटिन्यू.
फ्लोक्यूलेशन और सेडिमेंटेशन वाला मिसिंग है, तो वो भी प्रोसेस होते हैं. देन फिल्टरेशन, क्योंकि एट द एंड ऑफ क्लीन इनके लिए जो भी पार्टिकल्स बच जाएंगे वो इससे रिमूव हो जाएंगे. देन पोस्ट क्लोरिनेशन, एज सर हैज ऑलरेडी मेंशन्ड, वो आगे ट्रीटमेंट जो है, मतलब जब हम सप्लाई कर रहे हैं उसमें इंश्योर करता है कि पैथोजेंस वगैरह ना. Now sludge management is also very important thing. So as we have removed this sludge, how do we manage it? So basically, if it is by centrifuge, what we do is we remove the water content of the sludge. So if the sludge is very liquid in consistency, then it is hard to manage. If it is solid, it is little bit easier. Also the volume of sludge reduces. So this is why it is important. And also the power supply, because these are very power consuming processes, so we need a regular power supply for this. Now we have wastewater reuse. We know that many of my friends have already told the limitations we have regarding fresh water. So we need to use wastewater also, and we need to treat it. But what are the challenges that we face? Firstly, the social stigma associated with wastewater. Like nobody wants to drink water from the toilet. So we need
it is clean. Even if it's clean.
Even if it is clean, like no one wants to. That is the social stigma associated with it. Then also, see, it is not just, when we talk about wastewater, it is not just sewage water. It is also industrial waste is present in that. So now when we mention industrial waste, automatically heavy metals, the pesticides, etc. come into the picture.
Depending on the specific industry.
Depending on the specific industry. So we need different methods. So like, as we have discussed, these methods, they are not just for, they are not very adequate for wastewater treatment. So we use different technologies like oxidation and adsorption processes to clean the wastewater. And I guess to conclude, I have this picture. I don't know if it is very clear.
We can see them.
But the pipes are supposed to carry clean water to the slums of Dharavi and the place where largest
treatment plant
is present, and that is also there. So you can imagine what are present conditions of India. So, and this picture I have taken from YouTube video of KK Creates. He has been to the Dharavi slum and discussed various issues. Drainage is one of them, so I have taken it from there.
Did you
can
put the
also
link?
watch it.
Did you put the link in the slides?
No, I haven't. That is why you guys can watch it and will also realize how privileged we are to discuss this issue and not face it. So,
नजर ध्यान से देख रहा था, सामने देख लो. Come on. That this is now the what you are listening is one of the most important parts. So best for the last. Continue.
Okay. Good evening, everyone. I am Sagar from second year, and my topic of presentation is water quality in standard. First, why we need this? We are using water in our day-to-day life for purpose of drinking, bathing, agriculture, and some of industrial use. But here question comes here, the water we are using, it's actually safe or not? For that we have for this water quality standards. Water quality standards are legally binding provision defining the desired condition of a water body based on its designated use. So there are some standards are classified based on these three main components: designated use, purpose of the water body, criteria, maximum allowable concentration of pollutants, anti-degradable policy, rule to maintain water quality. And these classification are defined by national agency like BIS, and CPCB.
Central Pollution Control Board.
And these are designated use, and for criteria, these are drinking water without a treatment, outdoor bathing, drinking water after treatment, propagation of wildlife, irrigation. All of this above, the most important part for our is drinking water standards. So these are parameters: pH, TDS, hardness, fluoride, nitrate, and iron. So my question is, if we have to explain this whole parameter to some normal people or guy with no background, so how can we do that? So for this we have water quality index. Okay, from this the slide is made by Vinith, and this is my part. Okay, water quality index. This index is used to this all parameters convert into a single number. So it also save time and efforts of general public and also policymakers to do better for their work. So next, this is a filler slide that parameter for quality: physical, chemical, biological, physical, temperature, turbidity, taste, and odor of water. Chemical, pH, acidity, alkalinity, some ions, chloride, sulfate. This is very important: BOD and COD, dissolved oxygen. Okay, and this is biological parameters: bacteria, algae, protozoa, and viruses.
Just a second. First is what is BOD?
chemical oxygen demand.
What is that?
Oxygen replace all the bacteria.
Mostly right. Anybody else? Vivek?
The amount of oxygen needed to completely degrade the bubbles.
Degrade the
Bubbles.
Okay. So main idea to this is for visualization. For this is poor quality of water, and this is obviously excellent quality of water. And this is our main idea is first we select our required parameters for quality rating, and for their importance we give them some weights, and simply sum of them to get this WQ. In this example, I have selected dissolved oxygen, next BOD, pH, and TDS. Next, I will simply do quality rating, then assign weight to them, and simply sum of them for water quality. Now we have these are when we get deeper into that. So how can we measure water quality and quality rating and weights? So for quality rating, this is Vn minus Vi upon Sn minus Vi into 100. What is Vn? Actually measured water quality for field value, and then Vi ideal value with 0 pollutant and 7 pH, and Sn is the maximum permissible limit for pollutant, and this is weight K divided by Sn, and here K is normalized constant for Sn.
What constant?
Normalized constant, like 1 upon sigma 1 upon Sn to get this Sn into 0 to 1 rating, and simply sum of them. After this we get this spectrum of water quality, that poor, fair, average, good, and excellent. For drinking purposes, good to excellent quality would be preferred. And these are very shocking results of water quality index, that India secured 120th rank out of 122 country. This data is by Niti Aayog, and these are reference for my source and images. Thank you, everyone.
Hello everyone, I am Pratisha Chaurasia. Enough with all the maths and philosophy. Let's actually discuss the last topic of our night, which is water quality modeling, and actually the backbone of how we'll actually implement all this water quality indexes and things that we're discussing. So what is water quality modeling? We can simply take it as simulating the water's journey, how water flows, what happens to it, or let's say the blueprint of actually how water is flowing all over the country or all over the place. It's like digital clone of the actual water system. So to discuss this, let's take an example. On the bank of Sabarmati river, let's say there is a sugar factory. Now, whatever the excretes of that sugar factory is, first of all, what all is excreted, like in what amount into the river, and where all that river's waters goes through. So that is understanding the water's journey or stimulating water's journey. Next, how much of contaminants does it hold? How much pathogens does it have? Hazardous substance that it has? It is understanding contaminants. And lastly, what are the software tools that we can use to save the water, reuse this as we pledge it? Currently, we are using EPNET for drinking water systems, which is a US-based system. Now, how we'll actually implement this applications for drinking water purpose, or even reusing it. So let's take an example. This is an agricultural farm. Okay. Now, this is an entirely new farm, and I have to plant an irrigation system here. So I'll not just go and plant pipes everywhere around here. I'll first have a blueprint in mind that, let's say, these are the rows, so I'll plant one pipe here, and then I'll have all of it mapped out before actually implementing it. So that is designing an entirely new system. Next is optimizing operations. I've planned out the pipes. Now I need to implement. I've planned out the pipes. Now I need to implement water tanks, how the water will flow, what are the pressure it's gonna be, from where the water is more required, where it is less required. So that is all is gonna be in optimizing operations. Next we have investigating problems. So let's say in this plant, in somewhere around the area, there is a chlorine decay. So we don't need to go and look around every place. Through the model, we can directly know that where exactly is the problem and how we can fix it.
What is chlorine decay?
Chlorine decay is like if in some place there is a like the chlorine is used for like filtering it. Yeah. So if the chlorine is like contaminated or it is affected by all the other pathogens, instead of actually chlorinating the water, it will start affecting the water in like a harmful way.
Again.
Like chlorine is used to filter out the water. So if it is affected by some pathogens or hazardous substance, instead of actually filtrating, it will react with that pathogens to like affect the water in a hazardous way.
The whole idea of using chlorine is that these kind of situations don't happen.
A lot of time chlorine can a chlorine can with bacteria it can mix in like results in few of these conditions.
Any examples? Continue.
And lastly, emergency preparedness. Since we already have a model, we can predict few of the problems which might happen, and therefore already have solutions for that, and already be prepared for whatever we have to do. Lastly, what are the we have two of the actual simulating power tools that we are currently using in India as of now, which is first was water quality analysis simulating program, and second is QUAL2B. Now these both are mostly the same. It's just the enhanced version of it. So let's look at it one by one. What is WASP? So WASP is mostly used in water bodies or reservoirs, and it helps to understand how much the water is contaminated, how much can it be used, and it gives us something called as TMDLS, which is total maximum daily loads, which is how much amount of contaminants can that particular water hold and still be used and still meet the quality references. And QUL2, the enhanced version of it, it gives you more of the how much dissolved oxygen it has, pathogens it has, and understanding all the other healthcare substances like nutrients and vitamins.